back to talking about parabolas, and we're used to them being in the form y equals ax squared. And an example of this is like a roller coaster in the shape of a parabola. Of course, we can draw an x-axis through the middle, spoiling a roller coaster because we're now talking about mathematics. And we'll say this is x and this is y. So on some parabola, so here's our parabola for the roller coaster, there's some point, the new stuff from this chapter is there's some point, we don't know where it is yet, along the axis that's called the focus. And there's some line similar distance away from it called the directrix. So those are the two vocab words you need to know, focus and directrix. Now what this is saying is, no matter how you draw it, there will always be a similar distance to the parabola, or from the focus to the parabola, and from the parabola straight up to the directrix. So any way you draw it, it's the same distance. That's why we have these two lines. Of course, mine's not so good at showing that, but that's what the focus and directrix are. It's saying that any way we draw it, we're able to create the equal distance from the focus to the line, to the parabola, from the parabola to the directrix. A much more clear way of looking at that is maybe this example, although not as real world. So here's the parabola, and there's this point above it called the focus, and this line below it called the directrix. And any way you draw a line from the focus to the parabola down to the directrix, it will be the same distance. That's where these two values will come from. The new standard form for a parabola that opens up or down is x squared equals 4py. And the reason this is a useful form, this is the standard form for up or down, is because the p value will really tell us where the directrix and the focus are, because on the xy plane, the focus is going to be some point 0, p. It's 0 in the x direction, but up p spaces in the y direction. And the directrix will be this line y equals negative p. Let me rewrite that. It'll be this line y equals negative p. So if you want to find the focus, if you know what p is, it's 0, p. And if you want to find the directrix, if you know what p is, then it's y equals negative p. Now in this chapter, in this section, we're also looking at parabolas that open left or right. So something like this. And the focus here is going to be p, 0. And the directrix is not going to be y equals because it's up and down. It's x equals negative p, which makes sense because it's a vertical line. And the standard form for a parabola that opens left or right is y squared equals 4px. So notice the difference here. When x is squared, it opens up or down. When y is squared, it opens left or right. So it's very important to keep in mind. It's very important to keep in mind. So a question you might have is, identify the focus and the directrix if the equation is x equals negative 1/8 y squared. Now, the first thing we want to do is identify it opens left or right, or up or down. So we can see the y squared term, and so we know this opens left and right. Left or right, sorry. It's not going to open both. It opens left or right because of the y squared term. If there was an x squared term, it opened up or down. And remember, we're used to seeing x squareds because we're used to things opening up or down, not left and right. So when you see this weird y squared, you know it opens left or right. Now, the first thing we have to do is we have to get it in standard form. Remember, the standard form is y squared equals 4px. So the problem here is we need to solve for y squared. The only way to do that is to multiply both sides by negative 8 over 1. So we have negative 8x equals y squared. Now that's in standard form. Now, the weird thing here is the standard form is y squared equals 4px, but here it only looks like we have y squared equals, and there's only one number here in front of the x. So what we need to do in our head is split that apart into what's 4 and what's p. How did they get negative 8 out of it? Well, negative 8 is actually 4 times negative 2 with that x in front, like that. So it's 4 times negative 2, that's how we got this negative 8, equals y squared. So p has to be equal to negative 2. Now that we know that, it's really easy to tell what the focus is. Remember, this one's going to open left or right. So when that happens, the focus is p comma 0, because the focus has to be in front of it, or if it opens left, it has to be in front of it. It's on the x-axis, not the y-axis. So the focus is negative 2 comma 0. The directrix then is x equals 2. So once, because x is equal to negative p, so negative negative 2 gives us 2. So what this is going to look like is the focus is at negative 2, 0. The directrix is x equals negative 2. So our parabola is going to look like this. And actually it's going to go through the center. All of these will go through the origin. You don't have to worry about ones that don't. That's what this is going to look like, with the focus here, this point, and the directrix x equals 2. Now, a graphing calculator can be useful for helping us graph it. It isn't useful for finding the focus or directrix. We have to do that by hand. And actually, this estimate of what the graph looks like should be pretty good. But let me show you how to graph it anyways. Remember, when we graph stuff, it has to be in y form. However, we have this in y squared. So if we want to solve for y, we're going to take the square root of both sides. So we have y equals plus or minus square root of negative 8x. What that means is there's really two equations here. There's the y1, which is plus square root of negative 8x, and the y2, which is minus square root of negative 8x. We have to graph both of them. And the reason we have to graph both of them is because this equation is not a function. It fails the vertical line test. It's not a function. So there's not one single thing we can plug in and find what this looks like. We have to plug two things in because it's not a function. Calculator doesn't actually like graphing things that aren't functions, but we can force it to do it in this way. And once again, this is not useful for finding the focus or directrix. It's only useful for graphing. So it's pretty close to what we thought. We knew it was going to open to the left and go through the center. Of course, we found out what the focus and directrix were. They're at this point and this vertical line. We're going to run through two other examples from the practice problems. It says write a standard form of the equation of the parabola with the focus of 0, negative 6 and the vertex at the origin. So the vertex of the parabola is at the origin. The focus is at 0, negative 6. 1, 2, 3, 4, 5, 6. What that means is that this is going to be a vertical one, or up or down one. It's going to be something with a line with a directrix up here that opens up and down. Of course, we don't know exactly what this is, but that's the basic idea. So, because we know this, this has to be an x squared one. What I mean by that is the standard form has to be x squared equals 4py. Because the only way we can get a focus on the y-axis is if it's an x squared one when we choose. So how we're going to do this is we know what p is. P is negative 6, so we have x squared equals 4 times negative 6y, or x squared equals negative 24y. That's the standard form. The last example is write the standard form of the equation with the directrix at x equals 3. Okay, the line x equals 3 is like this. So this is going to be a left or right parabola because the vertex is at the origin. It's going to be something like this. So if it's a left-right parabola, the form is going to be y squared equals 4px. That's the standard form of the equation. And we just need to find out what p is. Now remember, the directrix is x equals negative p. So it's just the opposite is what p is. So we have y squared equals 4 times negative 3x. We have y squared equals negative 12x. That's the standard form of the equation.